A pool ball leaves a 0.80 meter high table with an initial horizontal velocity of 3.8 meters per second. Predict the time required for the pool ball to fall to the ground and the horizontal distance between the table's edge and the ball's landing location. So here we go. I'm going to create a sketch here where right there's the edge of the table, that's the leg, and then there's the floor. And then if I have a pool ball right here, can I say anything about that pool ball? The first thing I can talk about is this distance in the y-axis, and I'm making it blue because it's in the y. Distance in the y equals 0.80 meters. But since I know that the ball is traveling in this direction, I'm going to add a negative sign. One other bit of information is the velocity, and this is initial because this is where it starts, equals 3.8 meters per second, and it's going to be in that direction. The direction the pool ball is going to take is like this. This is the parabola, and eventually it will hit the floor. So now I need to take what I know in order to solve for t fall. Now, if you've been doing phenoms for a little while, if you've been doing the kinematic equations, you will recognize that as soon as we have a distance in the y, I can go figure out time very quickly. The distance in the y equals negative 0.80 meters. Now, we need to be careful. It is very common for students to instantly look at this velocity, ooh, it looks good, and they want to apply it to these givens. But you cannot do it. Once we are talking about the y-axis, you need to continue to talk about the y-axis. There is something we can talk about, the velocity initial in the y-axis. For a split second, that pool ball hangs there, and so we can apply 0 meters per second. We know one other thing about the pool ball, that it falls at an acceleration due to gravity is negative 9.8 meters per second squared. The thing that we're looking for is the time fall, that's question mark in seconds. And now, given that I have a distance, a velocity initial, an acceleration, and a time, I need to find an equation to use. I believe if you look at distance equals velocity initial times time plus 1/2 acceleration times time squared. We have a distance, we have a velocity initial, we're looking for a time, we have an acceleration, and we're looking for a time. So now, if I substitute numbers for letters, I get negative 0.80 equals, velocity initial is 0 times time plus, now I'm going to put this all over 2, 1/2, okay? Acceleration equals negative 9.8 times time squared. Alright, if I try to simplify, I see that 0 is times time. That means that this blows up. I'm going to write it again, a little bit simpler. Negative 9.8 times time squared over 2. In order to simplify the right side, I'm going to multiply by 2. This allows me to cancel. Whatever I do to the right, I do to the left, giving me negative 1.6 equals negative 9.8 times time squared. In order to get t squared all by itself, I'll divide by negative 9.8. Cancel. Whatever I do to the right, I have to do to the left, giving me time squared equals 0.163265, and then I take the square root of this to get rid of the square, giving me a result of time equals 0.40405 seconds. Now, I can make it pretty by applying significant figures, and the only number that is going to dictate significant figures is this one. Because it has 2 sig figs, I'm going to apply my time to have 2 sig figs. And so I'm going to respond 0.40 seconds. Alright, once I have time, I can use that as a given for my next problem. But let's talk strategy here. Do I want to use the really accurate number or the number that's been significant figured as a time in my next given? I probably want to use the really accurate one so that my number in each calculation is as good as it possibly can be. So I have a time. What else do I know about in the x-axis and only the x? You will see that we are working in the x-axis now. I do know a velocity initial is 3.8 meters per second. But in reality, do I know what the pool ball's velocity is right here as well? It is 3.8 meters per second. And here it is 3.8 meters per second. Is the ball speeding up? Is the ball slowing down? Is the ball accelerating in the x direction? Is the ball decelerating in the x direction? No. So it has 0 acceleration in the x direction. The thing that I'm looking for is distance in the x, that's question mark meters. And so now I need a formula that deals with time, velocity initial, acceleration, and distance. I think you'll find that distance equals velocity initial times time plus 1/2 acceleration times time squared. Now, if I replace numbers for letters, I don't know what D is, but I do know that velocity initial is 3.8 meters per second times the time 0.40405 plus the quantity 0 times 0.40405 squared, all of that over 2. Now, it is very common that students want to instantly multiply both sides by 2, but this 0 multiplied, the fact that there's a 0 here multiplied by this number, does that cancel out, giving you a 0? And then 0 divided by 2, does that cancel out as well? All of this blows up, leaving me with distance equals 3.8 times 0.40405. Distance in the x equals 1.53539 meters. And now to apply significant figures, I still only have 2 significant figures, giving me an answer of 1.5 meters.